The Earth and the Moon are basically the same distance from the Sun, yet temperatures on the Moon average an unlivable -18 degrees Celsius. And even deadlier, they range from -170 Celsius during lunar night to 100 Celsius at lunar noon, regularly exceeding both the coldest and hottest temperatures ever recorded on Earth. And while the days and nights on the Moon are about 14 times longer than those on Earth, our planet's relatively fast rotation isn't what spares us from those loony temperatures. What protects us is our atmosphere. By day, it serves as a shield, blocking out the most harmful and energetic of the sun's rays and about 1/3 of the less intense but visible light. At the same time, it traps the infrared radiation, aka heat, radiating out from Earth's sun-warmed surface, keeping us from freezing solid at night. In order for our atmosphere to absorb any kind of radiation, it needs to have some electrically charged particles for passing electromagnetic waves to push around. And most of our atmosphere is made up of gas molecules that don't have an electric charge. They all have a balanced number of positive protons and negative electrons. But some molecules hold most of their negatively charged electrons closer to one side, lending them a lopsidedness that can jiggle back and forth to absorb the energy of incoming infrared rays. For example, water, ozone, and nitrous oxide are all electrically lopsided, so they all absorb infrared radiation. Then there are gases like carbon dioxide and methane. On paper, neither molecule looks lopsided, so it doesn't seem like they should be able to absorb any radiating heat. But in reality, gas molecules aren't motionless. They crash into each other billions of times per second, knocking each other in different directions and also into different modes of rotation and vibration. And it turns out that both carbon dioxide and methane spend most of their time shaking it in electrically lopsided ways, allowing them to absorb infrared rays and help insulate the Earth. Even though many different kinds of molecules can absorb infrared radiation, the vast majority of our atmosphere can't, because it's made of nitrogen and oxygen, which don't get lopsided even when they are vibrating. They're too symmetric. Nevertheless, the lopsided 1% are such good infrared absorbers that they manage to intercept about 90% of Earth's outgoing heat. Each captured ray gets pinged around the atmosphere, and most end up returning to the surface at least once before escaping to space. We don't need to visit the Moon during frigid lunar night to know just how important the game of radiation pinball is for Earth. Ice records from our own coldest climate show that small natural variations in atmospheric carbon dioxide produce relatively big changes in temperature. They also show that, compared to the last 800,000 years, the game today is much, much harder.
This is a simple explanation of climate change, based on an article in the New York Times. The average temperature on the surface of the planet has already increased 1.7 degrees Fahrenheit since 1880, which may not seem like much, but think about it this way. The heat from human emissions is roughly equal to 400,000 Hiroshima atomic bombs exploding across the planet every single day. Future generations are in big trouble, but for now, it'll gradually continue to get warmer and storms will grow more intense, with longer periods of drought in between. But longer term, if emissions continue to rise unchecked, the climate disasters will be so severe they will destabilize entire nations, send millions of refugees across borders, cause widespread extinction of most species on Earth, and melt the polar ice caps, leaving most of the world's coastal cities several feet underwater. All this could take centuries, but something like the sudden collapse of agriculture would trigger immediate chaos in society. Best case is we get our act together and begin to rapidly bring emission levels down. Meanwhile, Earth turns out to be less sensitive to greenhouse gases than we currently believe, plants and animals adapt quickly, and major technological breakthroughs help society limit emissions and adjust to climate change. But these are all the opposite of what we're actually seeing, so the only thing in our control is to limit emissions using all available tools and best behaviors currently at our disposal. Worst case, the collapse of food production causes spiraling prices, and as our capitalist utopia breaks down, billions starve as our world gets violent and messy real quick, kind of like a zombie apocalypse, but with extreme hunger spreading chaos instead, so yeah, still just like a zombie apocalypse. This would be coupled with the melting of the Antarctic ice sheet, leading to rapidly rising seas that would force us to abandon many of our greatest cities and all of the social and scientific progress that we were making within them. Adding insult to injury is the fact that many of the emissions were emitted while building these now abandoned underwater metropolises. If emissions continue unchecked, we're looking at a total rise of between 80 to 160 feet, which would occur if all the ice in the poles melted. So the oceans will rise. The real question is how fast. Scientists only have Earth's history to base their predictions on, which suggests that the rate has occasionally hit 1 foot per decade, so we'll have to adapt to an altered coastline sooner or later, but probably much sooner than later, because computer forecasts only give us a range of future possibilities. The most important evidence comes from the study of past climate conditions, which clearly show that every time the amount of carbon dioxide in the air rises, the Earth warms up, ice melts, and the ocean rises. What's important to remember here is that we are in uncharted territory. Humans are pumping carbon dioxide into the air far faster than nature ever has before us.
By now you've heard that the way we're living is filling up our atmosphere with carbon dioxide. As a result, the planet's warming. Heat waves and floods are more likely to be extreme, and people's lives will get tougher. And the more we learn about climate change, the more risks we uncover. Since we started burning fossil fuels, the ocean has absorbed about half of all the CO2 we humans have put out. That's why it's called the planet's biggest carbon sink. Now this is good because it's kept a lot of CO2 out of the atmosphere. But as the ocean warms, it takes up less and less CO2. And with all that CO2 in the sea, scientists are shedding light on, well, an ocean of problems. Ready for the first big problem? Some sea creatures like clams, oysters, and coral, their shells and skeletons are getting weaker. Okay, you've got bigger problems than easy-to-crack clams? Maybe not if you're among the 1 in 7 people who get most of their protein from seafood. Or if you understand how unstable the world would be with 1 billion more hungry people. What's weakening the shells? Well, these little creatures are going about their lives scooping up molecules called carbonate ions to be the building blocks of their shells. But when CO2 reacts with seawater, it releases hydrogen ions, which compete with shells for carbonate. With more hydrogen ions floating around in the ocean, our little friends have to spend more energy building their shells and have less energy for finding food. That means it's harder to grow, and more will die off before they get big. So the fish that eat the clams or live among the coral will have a harder time surviving, meaning the fish that dine on them won't have enough to eat, and so we won't have enough to eat. Remember those pesky hydrogen ions generated by more CO2? They don't just take away the carbonate ions that these little clams need, they also make the ocean more acidic. It's already become 30% more acidic since we started spewing all this CO2, and it could get much worse. We could change the ocean's chemistry so much that shells actually start to dissolve. That means if we don't turn this problem around, your great-grandkids might think of reefs the way you think of a dodo bird. And with 1 in 4 ocean species living in coral reef ecosystems, weaker coral could threaten the foundation of the whole ocean food chain. But things don't have to get that bad. We've started this problem, and we're going to fix it, beginning at its source, carbon dioxide from burning fossil fuels. Learn more at acespace.org.
It's really cold out, and right on cue, Twitter has been overrun with climate deniers cracking tired jokes about global warming. But beyond social media jabs lies a serious and ongoing discussion about how scientists connect extreme weather, be it a cold snap, a hurricane, or California's extreme fire season, to underlying climate change. Because the truth is, this science is really new. The first proper climate attribution study was published in 2004. Before that, scientists had struggled to explain exactly how specific weather events were connected to climate change. Now, more and more solid, peer-reviewed studies show how climate change affects the likelihood and severity of extreme weather. And the studies are getting published really quickly after extreme weather events take place. Remember that study from 2004? It looked at a European heat wave that took place in 2003 and took a year and a half to complete. In contrast, just 3 months after Hurricane Harvey, scientists at Lawrence Berkeley National Laboratory published a study showing that Harvey dropped 38% more rain than it would have without underlying climate change. Another group, called World Weather Attribution, found that hurricanes that size have become 3 times more probable. Here's how Miles Allen, one of the authors of the first climate attribution study, explained why studies today are getting published so much faster.
When we performed the study in 2003 looking at the European heat wave, nobody had actually attempted to quantify the role of human influence on climate in a specific weather event. We are now looking at accelerating that whole process, because once you've agreed on the method you're using, you don't need to reinvent the wheel. The actual time it takes to actually do the calculations is not that long.
The developing science of attribution means scientists will have to completely reevaluate how they talk about extreme weather. Because terms like 500-year floods and 100-year droughts, terms that are supposed to indicate the frequency of a hazardous event, are becoming less and less helpful as frequencies keep changing. And it also means that in a few months, scientists should be able to explain the relationship between this cold snap and climate change. And projecting further into the future, it's entirely possible that we will soon hear scientists make these links as these events are happening.
We should be able to do this much faster, but in my view, in the long term, this should be part of the duties of the Weather Service. It's no longer enough for the Weather Service just to predict the weather. They should be in the business of explaining it as well.
While no single wildfire can be said to have been caused by climate change has been making the fire season in the United States longer and, on average, more intense. I'm John Holdren, President Obama's science advisor, here to talk about climate change and wildfires, a topic that's on the mind of many who are grappling with tragic losses from the recent spate of uncontrolled fires in the northwestern United States and Canada. The influence of climate change on the wildfire regime comes not just from the higher summer temperatures and reduced summer soil moisture that go with global warming. Climate change is also bringing us more dead trees, kindling in effect, killed by a combination of heat stress, water stress, and attacks by pests and pathogens that multiply faster in a warmer world. The National Climate Assessment released in May tells us, consistent with earlier studies, that longer, hotter, drier summers are projected to continue to increase the frequency and the intensity of large wildfires in the United States. In the western United States, the average annual area burned by large wildfires has increased several-fold in recent decades. The evidence is strong that climate change is responsible, at least in part, for this increase. And the West is not the only U.S. region affected by wildfire. Today, the southeastern United States leads the nation in number of wildfires, averaging 45,000 fires per year, and this number continues to increase. And nationwide, the 8 worst years on record in terms of area burned have all occurred since the year 2000. Wildfires, of course, are dangerous to human life and health, costly in terms of property loss, and generally harmful to ecosystems. They destroy valuable timber and wildlife, as well as homes and other built infrastructure. They promote soil erosion. They increase the risk from floods and landslides. And the damage can extend far beyond the location of the fire itself, through the impact of the smoke plume on air quality far downwind, and the destruction of downstream fisheries choked with silt eroded from slopes denuded by fire. In short, wildfires accentuated by climate change are putting communities, lives, health, jobs, and valuable natural resources at risk. I encourage you to learn more about the science of this issue by visiting whitehouse.gov/climate change.
Well, only in America is it controversial for me to begin tonight's program by declaring that global warming is really happening. For doubters, 332 straight months of above average temperatures is not proof enough. And even among believers, there's a fight over who to blame, God or man, natural cycles or fossil fuels. The very words climate change were noticeably absent from this past election, but Sandy brought them back in a big way, and eager to fuel the conversation, 2 artists convinced that they can help skeptics see climate change in ways scientists cannot. If you drive outside of Juneau, Alaska, and paddle across this gorgeous lake, past Nugget Falls and through the blueberry-colored icebergs, you will find Mendenhall Glacier. what's left of it.
So the ice came out to right about here in 2007.
Wow.
Yeah.
5 years ago, we'd be bumping into the glacier right here.
Yeah.
And if you time your visit just right, you might run into James Baylog, nature photographer, geomorphologist, and reformed climate change skeptic.
Honestly, when I first heard about the man-made climate change story, I sort of had a knee-jerk, reflexive skepticism.
But the more he learned about ice, the more he worried. The more time he spent in the Arctic, the more he saw ancient glaciers disappearing before his lens, and the more he thought about his kids.
And I imagined myself as an old man sitting on a rocking chair, and I hear my daughters saying to me, you know, what were you doing when this monumental change was happening?
And so he launched the Extreme Ice Survey, an effort to capture the changing planet by placing time-lapse cameras at the top of the world. And as you can see in the new film, Chasing Ice,
Look at that. Look at the whole thing.
that is no easy feat.
This knee has had 2 surgeries on it already.
Between the bum knee, the godforsaken cold winds, and the fragile cameras, the whole thing nearly killed him.
The electronics cost me years of my life in terms of anxiety and tension and high blood pressure and just general emotional suffering.
That's interesting to know, considering I've seen some of your critics online who say you're in this for the money.
Yeah, right. Well, you know what they can do? They can kiss my you-know-what about 10 times.
But 5 years later, here is just one small taste of the fruits of his labor, visual proof of Mendenhall's steady retreat. Now in the winter, will this come back?
The retreat will tend to slow down in the wintertime.
Okay.
And maybe it even stabilizes or creeps forward a tiny little bit. But boy, as soon as the warming season comes back on, it continues to gobble itself backwards.
The satellite pictures back that up. Since '79, half of the Arctic sea ice has disappeared. And just this year, 4.5 million square miles melted away, an area the size of the US and Mexico combined.
Okay, here it comes.
Meanwhile, back when Jim was mounting his first ice cameras, an artist in Brooklyn named Eve Mosier was pushing the kind of machine you use to chalk lines on a ball field. After reading a scary 2001 prediction from NASA that climate change-powered storms would wipe out entire neighborhoods, she decided to see which neighborhoods by marking the high water line around New York City.
This would be underwater, this would be dry. So there'd be a little dry strip down the center of the road, and all of this would be underwater.
The chalk was gone by the time Sandy hit, but the lines were right. And in many places, the damage exceeded her worst fears. And suddenly, that wishy-washy conversation changed.
Not so much of an I told you so as I'm really sorry this had to happen. You know, the fact that it takes something so drastic, despite the fact that his people in his administration know about it. You know, that it really takes us having a visceral experience to shift even the conversation, much less actions.
America is the last developed nation still arguing over all of this. On one side, those with the faith that humans could never alter the planet so profoundly. Happy to agree are oil and coal companies, and a political party strongly opposed to any new environmental regulations.
President Obama promised to begin to slow the rise of the oceans and to heal the planet. My promise is to help you and your family.
On the other side are 99% of climate scientists with PhDs and the president.
I am a firm believer that climate change is real, that it is impacted by human behavior and carbon emissions.
And happy to agree are most of the insurance companies that insure insurance companies, like Munich Re. The German giant reported last month that North America is getting the worst of it, as weather disasters cost 30,000 lives and over $1 trillion in the last 30 years, as storms quintupled. And they're warning clients to brace for much more as the melting accelerates.
In 1984, the glacier was down there 11 miles away. And today, it's back here, receded 11 miles. The glacier's retreating, but it's also thinning at the same time. It's like air being let out of a balloon. You can see what's called the trim line. It's the high water mark of the glacier in 1984. That vertical change is the height of the Empire State Building.
Skeptics will note that on the other side of the planet from Baylog, Antarctic ice is actually expanding to record levels. But that is cold comfort when scientists explain that North Pole ice is melting 8 times faster than the South Pole ice can grow in the winter, 25 times faster in the summer.
Now we turn on our time lapse. You can see the terminus retreating, you can see this river being formed, you can see it deflating. You go back a couple years in time, that's where it started. That's where it ended a few months ago. Now down onto the side of the glacier, looking across the terminus, this is what we see. Look at this. You'll see deflation happening here as the heat takes away the surface of the glacier and the surface drops. At the same time, a stream is undercutting it from a glacier that's melting faster up valley, washing this thing away. The vast majority of glaciers in the world are retreating. Glacier National Park, Montana will need a new name. We'll be calling it Glacier-less National Park by the middle of the century because all the glaciers will be gone. There's such a strange, bizarre fascination in seeing these things you don't normally get to see come alive. We're up at the Columbia Glacier in Alaska. This is a view of what's called the calving face. This is what one of our cameras saw over the course of a few months. The action at Columbia is in part due to local glacier dynamics and in part due to climate change. Here's another time-lapse shot of Columbia. And everybody says, well, don't they advance in the wintertime? No, it was retreating through the winter because it's an unhealthy glacier. We realized it was retreating so far, we had to turn the camera upstream to follow the retreat. Then we had to pivot it again. And then, when we went back this past August, it was so far out of frame, we had to turn the camera one more time so we could still see the glacier. So that's where we started 3 years ago, way out on the left. That's where we were a few months ago, last time we were into Columbia.
Work we've done recently on the Yukon Territory in Canada, where we looked at the change in glacier area from 1958 to 2008. And what we found was, of the 1,400 glaciers that were there in 1958, 4 got bigger. Over 300 disappeared completely, and almost all of the rest got smaller. Yes, there is a component of natural variability in the climate change we observe, but it's not enough to explain the full signal. So there has to be a greenhouse gas element to it.
Up to the Ilulissat Glacier calving face, a little helicopter is shown for scale. The Atlantic Ocean is on the left side of the frame, covered with icebergs so thick that you could walk across the ocean and never touch it.
Still going? Yeah, in that V section right there. Holy shit, look at that big bird rolling. All 4 are running, right? Yeah. Look at that. You see how, look at the whole thing.
faces 300, sometimes 400 feet tall. Pieces of ice were shooting up out of the ocean 600 feet and then falling. The only way that you can really try to put it into scale with human reference is if you imagine Manhattan. And all of a sudden, all of those buildings just start to rumble and quake and peel off and just fall over and roll around. This whole massive city just breaking apart in front of your eyes. We're just observers, these two little dots on the side of the mountain. And we watched and recorded the largest witness calving event ever caught on tape.
So how big was this calving event that we just looked at? We'll resort to some illustrations again to give you a sense of scale. It's as if the entire lower tip of Manhattan broke off, except that the thickness, the height of it, is equivalent to buildings that are 2.5 or 3 times higher than they are. That's a magical, miraculous, horrible, scary thing. I don't know that anybody's really seen the miracle and horror of that. It took 100 years for it to retreat 8 miles from 1900 to 2000. From 2000 to 2010, it retreated 9 miles. So in 10 years, it retreated more than it had in the previous 100.
One of the really troubling things about climate change is that almost all of the world's prestigious climatologists are much more frightened about all this than the public is.
People have a hard time understanding when we talk about climate change. What for me is so powerful and actually unprecedented in the work that he is doing is visualizing the change that allows us to actually see what was and what is becoming.
You can't deny it.
By fueling extreme weather events, undermining our military readiness, exacerbating conflicts around the world, climate change is a threat to the security of the United States, and indeed to the security and stability of countries everywhere.
America is well known for being one of the world's biggest polluters and for partisan rancor over climate change in Washington. But one of the country's most powerful institutions has been well aware of the threats climate change poses for decades.
We have been thinking about this issue of climate change, what effect it could have on our bases, our national security, how it would change infrastructure, how it would threaten infrastructure, and as the sea levels rise, certainly that is going to impact on security issues.
Measuring, observing, and analysing future risks is the American military's bread and butter. It labelled climate change a risk to national security in 2007.
To the extent that the military services lose access to the training ranges or even the installations for operational purposes, there is a potential mission capability impact.
The armed forces are also worried that climate change could play a role in the conflicts of the future.
It becomes a link which, when combined with other bad things, this is a threat multiplier, you can end up with a very unexpected outcome.
While the role climate change plays in conflict is sparking debate in some quarters, a more immediate risk is already lapping on the Department of Defense's doorstep. America has some 7,000 military bases around the world. A growing number of them are being affected by rising sea levels and extreme weather.
This base is the largest naval base in the world. We have an ideal location. We are at the mouth of the Chesapeake Bay, which gives us water in 3 directions.
In the 20-odd years that Captain Ray Toll, who runs the Mitigation and Adaptation Institute at Old Dominion University, has been here, the change in sea level and weather has been palpable.
We have had buoys in the water for over a century, certain areas, and they've been showing that over the last century, the water is rising by 6 millimeters a year. And from our science, we know that that is baked in for the next 100 years.
More severe weather can be costly and disastrous. Every time the wind goes above 50 knots, the fleet stationed here has to go to sea at a cost of millions of dollars. In 2003, Hurricane Isabel generated an 8-foot storm surge that flooded Langley Air Force Base and caused hundreds of millions of dollars in damage. The concern is that climate change will make these events more frequent.
At Fort Irwin, they got as much rain in 80 minutes as they get in a year. It's a desert area, and the water just rushed through the installation. It caused $64 million in damage to the installation.
In 2013, the Department of Defense commissioned America's Government Accountability Office, the investigative arm of Congress, to look into the threat climate change poses to its bases. Brian Lepore runs the bit of the GAO that manages defense matters.
We went out to a sample of 15 bases around the world, and we essentially asked them, are you seeing any of the following things? Let me give you some specific examples. Are you experiencing rising sea level? Are you seeing more severe storms more frequently? Are you seeing drought conditions? All 15 of the installations indicated they had observed at least one of those. In many of the installations, they had observed many of them. To the extent that the military services lose access to the training ranges or even the installations for operational purposes, there is a potential mission capability impact. The ability to do the mission can be degraded, training can be degraded as well.
Secretary Chuck Hagel addressed the effects of climate change on the world's security environment during a speech yesterday at the Conference of Defense Ministers of the Americas in Peru. Secretary Hagel said climate change has the potential to exacerbate many of the challenges the world already confronts, from the spread of infectious diseases to spurring armed conflicts.
That opens up sea lanes in the Arctic, meaning more countries and more commercial firms, oil companies, mineral companies, will start moving into those areas. There will be militaries that move into those areas. And that begins a race for minerals, natural resources, with the possibility of militarization of those areas, or the closing of, or the limiting of navigation in those areas. The potential for conflict, when that occurs, is real.
He uses the events surrounding Syria's record-breaking drought last decade as an example.
Assad said, you know, we're gonna be self-sufficient in food. And the way they did that is they basically overused their existing water. And then things nothing to do with climate happened. The Iraq War in 2003 dumps 1 million people into the cities, primarily Iraqi refugees.
When drought struck the country again, the situation worsened.
Remember, they used up all the reserves. So the farmers now, about 750,000 of them, went into the cities because they had nothing. This is not a place that takes care of its population. So you have ended up through a very complex series of events with a lot of insurgencies and a very fertile ground for ISIS.
Admiral, as you and I have talked about before, I'd like to get clarification on one statement that was, I think, misrepresented. It was in the Boston Globe. Reported that you indicated, and I'm quoting now from the Boston Globe, the biggest long-term security threat in the Pacific region is climate change.
A team of scientists is hoping to get the attention of those world leaders in New York. They want to show off a dark side of climate change in the Arctic, which could have global effects. Duncan McHugh shows us what they're talking about.
As far as the eye can see, this is what vast sections of Greenland's ice sheet looked like this summer. Not the snowy white north we imagine. And the glaciologist who recorded the images is sounding alarms.
What happens in the Arctic doesn't stay in the Arctic. And that's because melting of Greenland will affect sea level rise around the planet.
For 2 decades, Jason Baux and his team have studied Greenland's ice. He's known for a while global warming is speeding up glacier melt. But this phenomenon, snow and ice darkened by soot, is happening faster than he ever imagined.
Soot, also known as black carbon, is released when you burn dung, coal, diesel fuel, and wood.
The soot, being black, absorbs more sunlight. Increased melting is the watery result. What almost certainly made things worse, smoke from this year's unprecedented Arctic fires, drifting to Greenland via jet stream, and catastrophic wildfire is the new normal, says this wildfire expert.
Fire has been increasing in Canada. It used to average about 1 million hectares, and now it's 2 million hectares. This doubling, we believe, is due to climate change, and we actually believe it's due to human-caused climate change.
Scientists believe algae may also be a factor. Whatever the cause, it's clear the soot is contributing to an epic melt.
This science message should be clear enough now to policymakers, decision makers, to forge policy that minimizes the risks from climate change.
These images aren't something politicians can ignore, warns this climate scientist turned politician who's calling on the federal government to adopt carbon taxes.
When I see pictures like this, it's very troubling. And when I look around the legislature and see my colleagues not wanting to step up and deal with it, I wonder where their courage is.
Jason Baux's research has yet to be peer-reviewed, but he released these images now, hoping world leaders at the climate summit will see them and act. Duncan McHugh, CBC News, Vancouver.
What just a few years ago was considered to be unrealistic has become true. Much larger areas of permafrost begin to melt.
Permafrost thaws. The organic matter in the permafrost thaws as well and begins to decay. The microorganisms start to eat it. If there's no oxygen, the microorganisms make methane. If there's oxygen, the microorganisms make carbon dioxide. Permafrost. Right here. Frozen dirt.
Releasing organic carbon trapped in ice for ages.
The Arctic is heating up faster than many other places in the world. And so we want to work there to look at the response of the environment to these rapid changes.
The message today: thawing of permafrost is more widespread and faster than anticipated. Once thawed, soils can turn to lakes or ponds, often with an altered biogeochemistry, one that favors additional production of greenhouse gases. The new study, Increasing Dominance of Terrigenous Organic Matter in Circumpolar Freshwaters Due to Permafrost Thaw, published in March 2018, found that organic carbon from permafrost melting is making its way into the waters of the regions.
These last few years is a lot of melting on the actual bluff surface, creating small streams. In our most recent trip, we were there for 4 or 5 days, and the size of the streams, we could visibly see them growing.
This particular type of carbon is good at absorbing sunlight, creating conditions for additional heating of surrounding soils, and to boost activity of methane-producing microbes. As a result, water bodies are getting increasingly darker and stratified, which affects a number of biological processes in these ecosystems. The authors write, our results demonstrate a strong terrestrial imprint on freshwater ecosystems in degrading ice-rich permafrost catchments, and the likely shift toward increasing dominance of land-derived organic carbon in waters with ongoing permafrost thaw.
We found, as far as the organic matter coming out of this hill slope, is that it's much more bioavailable, meaning it's yummier for the microbes that are decomposing it. Sites like this, where the permafrost is releasing organic matter, act as accelerators. They speed up the process of human-caused climate change.
It's very much like the canary in the coal mine. If you're likely to see anything related to climate change, it will happen in the Arctic. There have been changes in the Arctic in the permafrost in terms of the temperature over time, not only in the shallow layers near the surface, but at 10, 20, and 50-meter depths, you're seeing changes that are even more rapid. That indicates that not only is there heating near the surface, but that this heat is being transported to depth.
Some of the affected regions resemble what could be a scenery from a science fiction movie with aliens. Entire landscapes with clusters of thaw ponds and muddy elevated cracks in between, like tendrils, curling up along its edges.
A new report just issued by NOAA says September's Arctic sea ice coverage was about 25% less than it was between 1981 and 2010. As America's only Arctic state, Alaska today faces unique challenges. One of those is the loss of permafrost, frozen earth that serves as the foundation for huge portions of the state. As we discovered on a recent trip to Alaska, the permafrost is thawing, presenting multiple threats.
For the past decade, Sue Natali of the Woods Hole Research Center has been taking trips like this, deep into the remote corners of Alaska's wilderness.
This area has been thawing for several decades now.
Her mission? Monitor how warming air temperatures are impacting the frozen earth underground.
We've come up via helicopter to see the Alaskan tundra from above. Right now we're not far from Denali National Park. About 25% of the northern hemisphere land area includes permafrost.
Permafrost is frozen ground. It's ground that remains below 0 degrees Celsius for 2 or more consecutive years.
Water, rocks, soil.
Everything in that ground that's frozen is permafrost.
But that term is actually misleading because, as Natali and other field scientists are learning,
You find a good flat spot.
the icy soil buried under this spongy moss is anything but permanent.
I'm going to dig a hole.
Recent studies show Arctic permafrost has warmed by up to 2 degrees Celsius in the past 3 decades and predict that 20% of it may thaw by 2040. Natali uses this drill to extract permafrost, which starts a few feet under the surface and can extend hundreds of feet down. It contains organic material from dead and partially decayed plants and animals. This is a permafrost core.
Yeah, this is how we sample permafrost.
Some of it's been frozen for thousands of years, but as it thaws, that organic material releases gases like methane and carbon dioxide, the so-called greenhouse gases that warm the atmosphere.
Our projections say for the larger permafrost region is we can expect 150 billion tons of carbon to be released by 2100.
Based on current emissions, the U.S. is already expected to release that much carbon over the same time period just by burning fossil fuels. This thawing permafrost would effectively double that figure.
We're inside the permafrost tunnel, so we're walking inside of permafrost.
The best view of permafrost does come from underground. In this 50-year-old tunnel, built and maintained by the U.S. Army Corps of Engineers just outside Fairbanks.
You can see there are these massive frozen structures that have formed over tens of thousands of years.
Down here, it's easy to visualize another danger posed by thawing ground.
And you can imagine if the permafrost thaws and this really large ice wedge here melts out, that you're going to have some pretty substantial ground collapse.
It's already happening in Alaska. Forests of trees bent or toppled over, roads like roller coaster tracks, even neighborhoods of homes buckling into uneven ground.
So originally the surface was flat.
University of Alaska researcher Alexander Kolodoff studies permafrost loss using hundreds of sensors around the northern hemisphere. He says the data from almost all those stations points to the same trend.
It is really warm, so it's really close to freezing point. So it's actually very, very vulnerable now.
You're right on the line there.
Yes, we are right on the line now, on the borderline.
Another possible side effect of permafrost loss, thawing remains of long-dead animals could release dormant diseases. Last summer, the first fatal Russian outbreak of anthrax in 75 years killed a child and sickened 20. But the more immediate impacts remain the rapid release of methane and carbon dioxide, and of course, if your house or your business is built on permafrost.
Fascinating.
We're here for a 3-week expedition to deploy some time-lapse cameras on the Antarctic Peninsula and on South Georgia. We've already told a powerful story of what's going on way up north. I've always wanted to tell the story of what's going on down here. Adding a story from this part of the world makes the archive that much more powerful. The peninsula is one of the fastest warming places in the world. The year-round temperatures at Palmer Station are up 5 degrees on average. 5 degrees is an enormous increase in warming. That's a big story, and the glaciers give us a chance to bring that story to life. South Georgia is a stunning place. I was completely unprepared for how spectacular it would be.
Hey, boys. Hey, boys.
In the early 1800s, this place was a hub for sealing and whaling. In 1914, Sir Ernest Shackleton's expedition stopped here on its way to Antarctica. His photographer, Frank Hurley, shot some pictures that document where the glaciers were on the beach. 1972, Phil Stone comes down and he does a study of ice positions as well.
Frank Hurley's photographs from the Shackleton trip are enormously valuable. The whalers took photographs, but they took photographs of the whaling stations and whaling activity. Hurley's pictures are probably the earliest we have of the general environment of South Georgia. The changes of South Georgia in the last century or so are really quite marked.
As far as the Extreme Ice Survey is concerned, we thought our real work was in Antarctica. And when we got here, I realized that South Georgia was an incredible opportunity for both art and science. South Georgia and the Antarctic Peninsula, down here in the air currents blowing around the southern part of the world. It's giving you a test for what's going on in these latitudes, and you can see the air and the climate changing through these glaciers.
Let's see this one. That's the one that was taken over there. Yeah. All the deflation that may have occurred could just throw off what we're actually looking at, but I think overall we're a little bit higher than what this photo is taken as. But good God, has that changed?
In 1972, Bertrab Glacier was this great big tongue of ice looking down out of the highlands, laying all the way across this area called Gold Harbor. We just got here and there's no ice on the beach anywhere. So big changes have happened here. Our pictures, repeating what others have already done, makes an amazing long-term record of how this area has changed.
We can follow the retreat of glaciers from satellites these days. They produce very precise numbers, but in many cases there's simply no substitute for a striking visual image. I think it carries power that raw numbers don't.
I no longer know how long the Extreme Ice Survey is going to go on. I thought it would only be a 3-year project. Now we're on year 8, and we're basically committed for 5 more years down here in the Southern Hemisphere.